Let us take a look at the second chapter of the data mining class, which is about the data preprocessing. This is the outline that we want to look at, starting with the idea of why do we need the data preprocessing. And then we want to look into how can we understand our data more. Then we want to do some data cleaning because we might have some missing value, we may have some noise data in our data set. So that we want to clean it and make it useful data that we want to mine from. We also need to deal with the data integration. Maybe the data comes from different sources, and how do we deal with it is going to be something important to discuss about. Finally, we want to transform our data into algorithm adaptable or computer adaptable data and make it easy for our algorithms, or make it easy for our programs to find the useful information out of it. So we see this slide before in our first chapter of the introduction, and now I want to emphasize it one more time. Starting with the original data set, we want to clean our data so that we can store that in somewhere, and therefore from that repository, or what we call the data warehouse, we can easily get the interested data for us to apply data mining, evaluate the results, and transform the information into knowledge. Needless to say, the first step is always the keystone of the whole process. We want to make sure the data that we collected is clean, is useful. So this is going to be the important steps that we need to deal with, starting with the first 4 steps, which we consider as the data preprocessing steps. And this, of course, is going to be something we want to discuss in this chapter. So we want to talk about data cleaning, data integration, data selection, data transformation, so that we would be able to apply our data mining algorithms to find the information from the large amount of data we are interested in. So think about this. If saying that you are a manager at all electronics company, and this can be Best Buy, can be Fry's, or anything that's related to even Amazon, and you have been charged with analyzing the company's data. So that might be something interesting. You want to find some new strategies, you want to understand our customers, and then you try to collect the data that the companies have and look into that. Then you realize the following things. Several of the attributes for carriers tuples have no value. That's pretty normal, right? And there's a lot of different things that you can input or you cannot input, such as customer's age. As long as they are not required information, most of the time they are not going to fill it. So what do you deal with the missing values? Or even something important, you have some products that you try to sell and you find out there is no price tag for that. That's something very weird. Some information you want is not on record. So like the address, a zip code, or something, education, degree, occupation. There's several things that you think that might be helpful, such as you want to promote some student discount for students. And you just realize that you don't have that attribute because the company never tracked if you are a student. This is something you can easily find, and some values are reported as incomplete, noise. Some product's price is negative $10. How can that possible, right? And inconsistent. So you have some same product and they have like 2 or 3 different tuples over there with different prices. So which one is the one that you really want to use? And you can find all of these problems everywhere, all the time. And welcome to the real world. This is something that you will face all the time. Like another data set that I personally working on is hospital data. We try to know the patient's basic information, including their blood pressure, including their glucose glucose values and many different motion test data. And most of the time, every patient has one or two attributes missing out of its 20 attributes. And how do we deal with it? That's something that you really need to think about. So this is a real world problem compared with the data set that you guys worked on in CS1 2 data structure algorithms. They are clean and simple and pretty straightforward data. Starting from this class, you will see that in real world, the data is not going to be as pretty as you see all the time. So we need to deal with it. So data in the real world is obviously going to be dirty. It can be incomplete. For example, lacking attribute of values, lacking certain attributes of interests, or contain only aggregate data. For example, no occupation is provided. It can also be noisy. So salary is -10. So what does that really mean? And that can be outliers as well. For someone's salary is like 20 million. Okay, and how would you justify that to make sure that it's the data that you want to use, or you simply want to discard those? It can be inconsistent. For example, you have an attribute called age, you have another attribute which is birthday, and they are not matching with each other. Some grades are using the point scale, some grades are using the ABC grade. Many different things that can happen. So how would you make sure your data is usable? And that's going to be an important thing for data mining. Why data is dirty? Well, many possible reasons, right? It can be not applicable data value when it's collected for someone that really don't have a college degree. That's why we discussed the null value in database class. It can be not applicable, or it can be unknown. So there's many different things that we can interpret from. Different considerations between the time when the data was collected and when it is analyzed. Think about this. If the database that the company has designed 20 years ago, the perspective at that time is very different from what we are seeing right now. But the data is going to be collected based on the old settings. So either you're going to change the new database design, or you find a way to use those old data. There's many different things that need to be put into consideration. And of course, there's going to be some human error, hardware error, software error, program error, many different possibilities that make the data not easily applicable into the data mining process. So noisy data or incorrect values can come from faulty data collection instruments. So sometimes we type in our values. Sometimes we use machines to record the force that is going to adapt, or there's many different ways that you can combine with what we call computer engineering with the data input, and in that case, of course, error can happen all the time. Human or computer error at the data entry, most of the time that people will need to hand type in things, and we all have these experiences when we try to type in our password. That's something we use all the time. Or when we try to type in our social security numbers, you may end up with one or twice of the errors when you input, because your fingers is not a machine. This is your hand. You basically need to manage it and stroke on the correct key all the time. It's not going to be that easy. Errors in data transmission, transforming from one data computer to another computer, transforming from one program to another program. A lot of things can happen in between. So inconsistent data may come from different data sources, because you may have 2-3 different data sources as we use Amazon. You can have Amazon JP, you can have Amazon United States, Amazon UK. If they can sell on the same thing, same video game. Say I basically purchase The Last of Us 2 from UK Amazon, and obviously it's not going to end up too well because I'm in the United States, and when I do that, there's some problems can occur. For example, I'm not able to get the updates when I play in United States. So there's a lot of different things can happen. Even though they are selling the same product, the price is going to be different. The shipping is going to be different. The laws and regulations can be different. So there's a lot of different things can happen, and that cause the inconsistent data. Functional dependency violation. For example, if we modify some linked data and they are not going to retrieve the original information anymore. For example, you say the first attribute is the birthday, the second attribute is the age, so that you can easily derive your age from your birthday. However, if the link is being blocked, saying that the first attribute is no longer birthday, you have changing something else, then you will break that program and you may get some inconsistent data. So duplicated records also need to be cleaned. So there's a lot of different things that we need to make sure the data we are about to use is clean. So without the quality data, there's no quality mining results. Quality decisions must be based on quality data, so that if you, for example, some duplication, say that you have one customer that has been duplicated over there for 10 times. And if you didn't catch that, when you apply data mining algorithms on that, that person or that record will have higher weight in the process, and therefore it will skew the results that you may find. And therefore, we need to make sure the data is clean before we apply data mining process. Data extraction, cleaning, and transformation comprises the majority of the work of building a data warehouse. So this is going to be a very, very important first step of the whole data mining process. So you can see that the major tasks in the data mining processing, including the data cleaning, data integration, data transformation, and data reduction. And therefore, these are the things that we want to discuss in this chapter. So you can see that this is actually a pretty interesting graphical representation. How do you want to wash your dirty data into a clean data? How would you incorporate? Sometimes you have a data warehouse, you have some database, and you have some files. They need to be integrated together. Obviously, there's going to be a lot of work need to be done so that we can have a clean data that we will be able to use. We also need to transform the data, saying that these values are recorded for one tuple. And you can see that they have big range differences between each other. How can we transform those data into a more normalized data that we can use easily? It's going to be what we call the data transformation operation. We also need to do the data reduction, saying that we originally have 2,000 tuples, say 2,000 customers, and we have 126 attributes that we want to find the information out of it. After the data reduction, we find out that many tuples are duplicated. So we may want to reduce those tuples into only about 75% of the data, which is about 1,500 customers with fewer attributes. Instead of 126 attributes, we can look into 115 attributes. This can be an example like Toyota dealer. The customers in Toyota Conway versus Toyota in Little Rock, this may have a lot of duplications over there. People live in Conway, of course, comes to Conway, but when I try to buy a car, I probably want to take a look of the car in Little Rock as well as the cars in Conway to compare the price and find the best deal. And in that case, my data will be duplicated. And while Toyota main company try to collect all the data from all the branches, my data has been duplicated, and so that they may need to reduce those data into a smaller amount so that they can get more precise information. Attributes. Sometimes the attributes are important, sometimes some of the attributes are less important. For example, like the zip code, the address, those kind of things may not be relevant to the target information that you want to find, and so that you may want to reduce the attributes that you put into your algorithm. While we do that, we of course can increase the performance of the program because we have fewer tuples with fewer attributes. So all of these are under the scope of what we call data preprocessing. Let's take a look at how do we describe the data that we have in hand and try to understand it a little bit more. The motivation, of course, is try to better understand the data. We want to find out what is the central tendency, variation, and spread of the whole data set. And data dispersion's characteristics, including you may want to find the median value, you want to know the maximum value, the minimum value, and because of those values, you can generate the quartiles. You can also come up with some outliers, variance, etc. And of course, the easiest way to understand this is through graphical representation, which is what we call the visualization of the data distribution. Numerical dimensions corresponded to the sorted intervals, so that if we want to understand the data dispersion, we can analyze with multiple granularities of precision. We can draw the box plot or quartile analysis on sorted intervals. So there are several terminologies we want to define before we move into the box plot. So mean value, average value of the data. Median value is the middle value of the data. If you understand the differences between the two, you will be able to understand the distributions a little bit more regarding to the data that you have, because average value, ideally, if they are distributed evenly, your mean value will very close to your median value. However, if your data is skewed, you will be able to catch that by comparing the mean value as well as the median value. Mod, indicating the value that occurs most frequently in the data. Database with 1, 2, or 3 mods are represented called unimodel, bimodel, and trimodel. So you can see this is what I'm talking about. If the data is symmetrically or evenly distributed, your mean, median, and mod value will be hitting in the middle. And this is like the regular distribution of the data. However, if the data is positively skewed versus negatively skewed, you can see that your mean value is going to be in here, your median value is going to be here, and your mod value is actually located over here. While you have a negatively skewed data, you can see that your mean value is right here, while your median value is over here and your mod value is over there. So by looking into those values, I would say mean value and median value are two very important values for you to understand, and you can understand what is the data distribution looks like of that attribute. Quartile, outliers, and box plots. To get more information about your values, box plot is actually a very useful tool that you can see. The median is the 50th percentile. Quartile, if you try to get Q1 and Q3, which Q1 indicating the 25th percentile and Q3 is the 75th percentile, then you can have your Q1, median, and Q3 that defines most of your data located distribution. And then based on that, you can generate what we call the interquartile range, IQR, which is use Q3 minus Q1. So that is the interquartile range between 75th and 25th percentile. And the outlier is that something outside of that range with additional excessive values. So usually a value higher or lower than 1.5 multiply the IQR is actually outside of the regular range, and therefore that's what we consider as the outliers. So 5 number summary. So we will be able to summarize minimum value Q1, median value Q3, and maximum value, and that forms the most important structure of the box plot. So the box plot is transforming in a box. The end of the box are at the first and the third quartile, so you have that IQR being pointed out quickly, and the median is marked in the line so that you can see it is evenly distributed or positively or negatively skewed. And then you can have whiskers, two lines outside of a box extending to a minimum and a maximum. So you can see that in say that this is the data with 4 attributes, and you can draw a box plot for every attribute, and you can understand for the first attribute the minimum value is like 38, maximum value is like 155, things like that, and you will be able to see the IQR range over here, and then the median value is provided. Everything else comes from the this is like from 0 percentile to 25 percentile, and some points that's outside of the what we call 1.5 multiplied IQR is going to be marked as the outliers. It can be over here, it can be under here, so that these are the things that we can easily see in case of the box plot, so that by looking into this we can easily understand the distributions of the data. The median for each data set is indicated by the black center line, as we see, and the first and third quartiles are the end edges of the red area, which is the IQR. Points are at a greater distance from the median, so counting starting from the median value, then 1.5 times of the IQR are plotted individually as asterisk. So you can see again, the maximum value in this data set, obviously the maximum value is 200. So why didn't we mark that over here? Because we consider that as outliers. Starting from the median value, and if we have the same space of the IQR plus 1.5, which is additional 50% of the IQR, we can find the maximum value is about here. Anything outside of this limit is going to be considered as the outliers, and the same thing for the lower values of the outliers. And that's how we will be able to generate the whole box plot through the data distribution. Of course, another way of distributing it, which what we use probably more frequently or more easily see, is the histogram analysis. Graphs display a basic statistical classes descriptions. Frequency of the histograms, a univariate graphical method, consists of the set of rectangles that reflect the count or frequency of the class presented in the given data. So you can see that by looking into one attribute, say the price, we can using the histogram analysis to look into that. Of course, this will take more space compared with the box plot. This is easy to understand, but box plot, in my opinion, can provide more information compared with the histogram. So I want to list them both and compare them side by side to let you understand box plot has more power to represent the information regarding to the data distribution.